Just sell cookies, and just buy cookies from the place.
No, the thing is, you buy your own uniform and then you sell their cookies.
Yeah, you have to buy your own.
I know.
What do you get out of it? Like,
They give you a cut.
Not really, not much.
That's the same thing as at school trying to make you sell cookies.
And my mom says, they're like, it's for a good cause. I'm like, no, it isn't. It's for the Girl Scouts to go on the field trip.
Yeah.
Yeah, that's
a good cause.
That's a good
that's a good cause for you to go on a field trip.
Keeps you off the streets hooking, so.
Oh, I can't believe you said that.
It's true.
Jeannie wanted me to tell you she's not gonna be here.
So, right.
Yeah, Jeannie said it. She had to go home early.
Oh. Keep it work.
How many good workers you have in that class?
The class is actually surprisingly good. The thing about Algebra 3, if you think about our Algebra 2 class, the half that, maybe they weren't the brightest, but they tried, they worked, they
You want
did
to
everything.
discreet.
Those would be the ones that go into Algebra 3, and the other half of the class that shouldn't have been there, they go to discrete or somewhere else. So when you get to Algebra 3, you're not the best math student, but you're good enough to do the work in front of you. You probably have a decent attitude about education. Even if you don't like it, you're at least quiet and polite and try, stuff like that. So Algebra 3 and above, you really don't have problems. You really don't. Algebra 2 is the brick wall. That's where a lot of people just mosquito on the windshield.
I'm just a gatekeeper there, just so you should not.
What is your favorite color?
Green, actually, white.
You don't get the reference? Monty Python and Holy Grail.
I do, I just actually want to answer the question. What's your favorite
It's
color?
wrong, you don't throw it off, the answer's blue.
Why is my favorite color blue?
But it wasn't
Oh, it's
blue.
that.
But my favorite color isn't blue.
See, I
We're
wouldn't have got thrown
now.
off a bridge because I went. I'm just saying.
I like
Do you know
blue.
the average airspeed of an unladen swallow?
What?
Do you know? You're like, okay, I know the movie.
No, he doesn't.
No, I didn't hear the question.
Do you know the average airspeed of an unladen swallow?
Then I would have thrown off the bridge. Yes, yeah.
I'm getting thrown off the bridge. I'm sorry, I don't even know what movie you're talking
Huh?
about.
I must have missed that part because I don't remember that.
I've heard of the what's your favorite color thing, though. I don't think I've ever seen the movie, but I've heard of the what's your favorite color. Probably
What,
good.
do you know the
That's how they trip up the troll. He's not a troll, but they trip up the little guy. If you answer wrong, you get thrown off the bridge. So he asked the first guy, what is your name? He's like, Sir Lancelot. What is your quest to seek the Holy Grail? What is your favorite color? Blue. All right, pass. He's like, oh, thanks. He the second guy, what is your name? Sir Galahad. What is your quest to find the Holy Grail? What is your favorite color? He said blue. No, yellow. And then he gets thrown off the bridge. This is Monty Python's British humor. Monty Python, it's hilarious. Then he gets to the king. What is your name? And he's like, King Arthur of the Britons. What is your quest to find the Holy Grail? And he says, what is the average airspeed of an unladen swallow?
He's like, oh.
By that, it was a gag at the beginning of the movie when they're talking about something else. But the king looks at him and goes, I don't know, do you mean African or English swallow? And he goes, I don't know. Ah! So he gets thrown off the bridge because he didn't know the answer to that question, and they all go by.
Big troll.
The troll got
The
thrown
troll
off the
gets
bridge
thrown.
because
Who threw the troll off?
it's all magical. Like they answer wrong, and they just
Oh,
get
okay.
hurled off the bridge. But they're the ones with the coconut. Have you
That's
seen the
a
movie
struggle.
where they're doing the coconuts and?
Yeah.
Aw.
And they get up to the first castle and they're like, we're here to see the lord of your castle. He's like, are those two halves of a coconut you banging together? He's like, that's not important right now. Is your lord at home? Where'd you get the coconut? Coconuts grow in the temperate zone. This is when he starts talking about that. And he says, then they start talking, could a bird bring a coconut here. I don't know, maybe if two of them flying together with a string tied between them, they're talking about a swallow being able to carry a coconut. So,
Oh, man, they're. Oh.
British humor.
well, certainly not in English. No, yeah, I'm talking about an African swallow, of course. Anyway, there's that. What's you?
Oh,
What did you try?
I tried Y for
That's what I
one.
tried.
Let's try y to the fourth plus one.
I think I ran into a problem.
I did too.
du would therefore equal 4y cubed dy. Alright, here's the thing. The 4, not an issue. I can get rid of a 4 all day long. It's a 1/4 on the other side. The part I'm really having trouble with is the third power. Okay? Because you can't get rid of it. If you try and get rid of it by taking the cube root, you're now doing the cube root of du, which makes absolutely no sense in this problem. Okay? And we don't have enough u's to accommodate that many. So, nice try, but when we pick this u, our derivative needs to hit the extra stuff perfectly. Not too much, not too little, just right. You gotta baby bear it, okay? Just right. So, nice try. That's exactly what I would have done first if I were some novice attempting this. So let's drop back and pick a different u. Let's focus on what went wrong. When you took a derivative, which is beautiful, you got too much.
Can we factor out? or
What
maybe
if
change the
instead of, what if we shoot for what we're trying to get rid of, this, okay? It's still a y. What would have had to have been used for u to get a y left over?
Y left over.
What should I have picked for u so that when I did du, I didn't get y cubed, I just got y?
Y squared.
Y squared.
Which would mean,
Okay, hang on. Y squared. Now, I cannot bring the y along for the ride, the 1 along for the ride. Because that 1 is attached to a y to the 4th and only a y to the 4th. Let's see what we get.
You take the 2.
2y dy. Okay, take the 2 out. 1/2 du is equal to y dy. Alright, I got some stuff to swap out, okay? Look at what happens with the y or the u that we've chosen. Okay, 1/2. Antiderivative.
anything
The y
So-
and the dy.
so it's now a u squared plus 1.
Use, good. If I only used 2 of these, then I got 2 u's left over, a u and another u. Got it. U squared plus 1 du.
Oh, I get it.
Not,
You okay with what just happened?
Yeah, I see what happened. I was like, wait, what are you doing? And now I see.
That's u, if u is this,
and you square.
and then you square it, you get 4 of them,
I get it.
okay? Now why is that so awesome?
Why
Because
is
the
the y
arctangent.
given?
Because it's the arctangent.
See, I remember.
Where is the y going?
Y dy became du. If you
Oh,
want,
okay,
if you
okay,
want
yeah,
to,
yeah,
you can
yeah.
write du on top. I tend to write it this way because y'all are used
Yeah.
to seeing 1 over stuff, okay? Does everybody recognize that as the arctangent?
Yes.
Good, alright, so,
Tangent's easy.
1/2 arctangent u plus c,
Yay.
which is 1/2 arctangent of, what was u? Y squared
Yeah, y squared.
plus c.
That's a fun derivative.
That one's good, not my favorite, but it is a nice one.
Guess what when you take a derivative of that, guess what you get?
Yeah, look at that, you can check yourself, you good.
I don't want to though.
Sometimes it helps to know what exactly, this is what I mean, what
What you're
exactly am I
trying to-
trying to turn it into, you know?
Which then you're trying to turn into a trig where everyone else, I was trying to turn into a polynomial, which we've been trying to. but-
Actually, what you were trying to do, I don't know if you knew it, but what you were trying to turn it into was a natural log.
Oh, it was.
because your u would have ended up on the bottom, and that's technically what natural log is one over thing. So you were trying to do, you may not have known that, but that's what you were trying to do as a natural log.
I figured after, I was like, no, like polynomials, what's the next after polynomials? Fractions. I don't think, and our trig, I think, log. Natural log.
Try this
Next
one.
on my list.
This one might be one that we hit a roadblock relatively quickly, but let's try this one. I'll give you a hint, it's not secant squared. Do you understand why people would say that? Because the derivative of tangent is secant squared, not the antiderivative of tangent.
So what's the antiderivative of tangent?
Yeah, that's a good place to start. Let me go through my list of trig functions to see if I remember anybody's derivative that is tangent.
I have, there's one that has a tangent in it.
But it's not tangent. Yeah, secant tangent from secant, but not just tangent. Ooh, then we create a quotient rule. Yeah.
Ugh. Why would you do that?
Sounds fun.
It does, doesn't it?
Slow, you're here. Sorry.
We're hewing it up in this place.
I'm doing use up today.
Oh. Lots of splice.
By the way, this is a U problem, U sub problem.
Yeah.
Okay, so what should we let U be?
Yeah.
There aren't that many choices up here for what U should be. Here's the rub though, if I let U be tangent, alright, that takes care of the tangent, but then I have to do du and get a secant squared. I don't have a secant squared in this problem at all to be used.
Aww.
I think that's actually kind of weird because
There's no sense in doing that. Other than tangent, there's nothing.
unless you tell us the secret.
You don't look at it as tangent.
Like we were saying.
Look over it. Cosine.
The other one, sine and
Sine and
cosine,
cosine.
right?
I always mess that up.
I want to say it another
The
way.
thing about U sub, you do need somebody to be the original and you need somebody to be the derivative. So you need at least two things in the problem.
So I guess we can use a cosine as the u.
Well, you have options. The derivative of sine is cosine. And the derivative of cosine is negative sine, so both have merit. Pick.
I feel like the bar didn't get it.
You want U to be cosine, alright? Let's test that theory. What is du going to be?
Negative sine.
Negative sine, good. Good.
Okay.
Alright. I got the cosine. The only thing that's bothering me is a negative, which we can just move over. So negative du equals sine of x dx. Okay, so I'm pulling a -1 out front, ninja -1. And, okay, the sine x dx, all that stuff right there becomes a du, and the cosine becomes.
Which is the natural log of u.
So this one was, not at first glance, this one was a natural log problem. The same way that one was an arctangent problem. Antiderivative for this one is going to be natural log of u plus c.
Do you want to do it,
Talk to me about absolute value, yes or no?
yes, because you can plug in negative.
In the original problem, positives and negatives actually work pretty cool. So we need to account for all the positives and negatives being pretty cool. Bring it home, let's swap out the u, negative natural log, absolute value, cosine x plus c. I would file that one away under important, because it's probably gonna show up on the AP somewhere, antiderivative of the tangent. By the way, it's not that hard to recreate, But if you go straight from here to here in about 3 seconds, that's kind of nice. Okay. By the way, I have seen in some books, I don't do this because most people like to work with cosines and sines, but I have seen them take this -1, pull it back inside as a power, then do cosine at 1 over cosine and turn it into secant. In some books, I've seen them
Natural
write
log,
natural log absolute value of secant. The problem with this is that most people don't work in secants, most people work in cosines anyway, sines and cosines, so I would prefer just leaving it in this form, because that's probably what you're gonna do anyway.
It's the same thing as saying natural log of 1 over cosine,
Yeah.
or the absolute value of cosine.
Not really that great. What else?
It's all the same.
Yeah. Okay. Let's see,
Words and stuff.
words and stuff. Alright. Let's try something else. Ooh, this is a good one. Okay. I think I get to this one today, this is a good one. I'd put a little star by this. That one, actually you can put a star by all these, they're all great, and they all have their own little twist to them. This one's gonna be,
Even better.
yeah, irritating.
Oh, that's great.
Alright, here we go.
At least you're warning us.
Alright,
Oh, it's so beautiful.
yeah, this one's all kinds of irritating and nasty.
Thanks. Well, we can rewrite it to be less ugly, or X.
How would you write it less ugly?
X.
Change.
Yeah, change it to.
X minus 3 to the 1/2?
Yeah.
Okay. I'll leave that to you, that's legal, doable, fine. Do that.
Okay.
More important question to me, what is U? If this is even a U sub problem.
I don't think it is.
You know what I'd try first?
Actually,
I like, okay, try it the way it is. Does that look like one of our formulas? Yeah, if it's product, that's painful because we don't get to unproduct. Sloan's trying it now, the unproduct thing, it's a busy topic. I pray that's not product rule.
Oh. Okay.
It's not, I'm afraid it is.
So you got this?
Slow go.
Okay, okay, it's not on my list of good ones, got it. Can I rewrite it so it is on my list? Could I, you know how, the one we did, I've erased it, was on the left side, the one with that little polynomial to the fifth?
Yeah.
Could we actually do something to expand this so that it turns into something that's nice, like a polynomial or something like that?
Yes.
Okay, how? By the way, that polynomial we did would have turned into a big one if we had distributed, right? Can we distribute that x?
No.
Why not?
Oh, yes,
Yes, why?
because it's being times by it.
Go ahead and distribute it.
Where's the square root?
It's not pretty.
The reason it's not pretty is because it wouldn't exist. You can't actually take that x and distribute it, because it's not, it is being multiplied, but it's being multiplied by a square root.
It doesn't work.
Chain, yeah. So all of our tricks
Chain.
so far aren't working. It's not one of our good properties. We can't rewrite it as a good property. Well, why don't we just try and force the U sub and see what happens? Let's just force it. What would you let U be?
Probably the 3 minus X.
Okay, here's the thing, you got choices. X minus 3, square root of x minus 3. Alright, or x. Why is choosing a letter not good?
Because then it just gets canceled.
Why would that
You
not
just
be
replace
good?
another letter with another letter?
The x has become used and it's still the same problem. So nice try, but not what I would have chosen, okay? What about this? Let's try it.
Okay.
du.
Du.
1/2, x minus 1 to the negative 1/2. Technically times 1, because we have to change that part right there. Anyway, this is what we get. Or 1/2 square root of x minus 1. Why is that a problem? We've now made a fraction that wasn't there to start with, and there's no way we're gonna find him to substitute out, so nice try. Which leaves
X minus 3.
something as simple as x minus 3.
Oh, well, why did you have the -1?
Yeah.
Sorry, 3.
It still doesn't.
Good call.
I was getting scared.
No.
I was wondering where that was too. I was just like,
It was all crap anyways, so let's throw it away.
could put a Z in there, it didn't matter.
Yeah. Alright, let's go for it. du.
Du, so dx.
Yeah, 1 dx or just dx. Okay, this is the closest we've come.
You replace the dx with the du.
Alright, so we can do this.
So it's now this x square root of u.
Yeah.
Oh, that's not pretty.
Or if you like,
You can take the,
And change it to.
if whatever, if you like.
yeah, it's still not.
What's the problem though?
There's an
I
x.
can't get rid of this.
Okay, what we need now, hopefully, 2 out of 3, yo. 2 out of 3. I don't necessarily want to give up on this so quickly. We got rid of 2 out of 3. If we somehow had a way of turning that x,
Into
just the x, into something that had u's in it.
we do know that x, oh wait, no.
What were you gonna say?
I was saying that
No,
x
that wouldn't
equals
make
u,
sense
but
either.
That's crap.
yeah, that's crap, so.
What were you gonna say?
I was just gonna say something about getting that equal x instead of u for that. But it,
Yes.
oh,
What would x equal?
U plus 3.
U plus 3. So I can rewrite x in terms of u. Okay.
Okay.
Now, how on earth is that helpful? It is importantly helpful, because now I can
Cancel.
distribute.
Oh, no, yeah, you
yeah,
can.
so you
I
just straight
can
into
distribute.
u.
What is u to the first times u to the 1/2?
U first times u to the 1/2, u to the 1/2.
No,
No, u to the 1 and 1/2.
1 and 1/2, or
3 halves.
what is 3 times u to the 1/2?
3 u to the 1/2.
Ladies and gentlemen,
That's
we just turned it into a polynomial, a couple of polynomials, okay? What is the antiderivative of u to the 3/2?
2/5 u to the 5/2. 5/2 plus.
Alright, antiderivative, yeah, good. Raise the power, you get 3/2, multiply the reciprocal, which is 2/3, the 3's cancel out, you get 2
2u.
u to the 3/2, slap a plus c, substitute in what u is, so 2/5 x minus 3 5/2 plus 2 x minus 3 to the 3/2 plus c. That one had style, okay? There was a whole lot of substitution going on in there. part for the calculus and did part for just algebra, just regular old dinky stuff. That is an elegant problem. Do you notice, up at the beginning, we could not distribute. This is trapped inside the radical. So yeah, we did substitution, but we did it with the intention of actually turning the problem into a polynomial by being able to distribute by swapping out the bad part here
good part.
for a good part here that would distribute. That's a clever one, okay? I think I've shown you enough examples today that hit on all the tricky little things, the things that are hidden use of problems, the things that you, this is probably one of the hardest thinking wise, how to swap out all of your variables and then some basic crap in the beginning. Now, I'm gonna leave you with this one right here for us to discuss. Okay? All right, go.
I don't like it.
I don't think we've ever said anything about e to the x to the something. Like, if
Oh,
it's not-
you don't like e to the x? E to
No,
the x is my
e to the x,
favorite.
but e to the x to the something.
Oh,
No, it's negative 2x, huh?
oh yeah, if it was negative 2x in front, that'd be a heyday right there. Woo, done.
But no,
All right, what are you gonna let u be?
probably negative squared, a negative x squared.
All right, and we all see where the problem's gonna be there, right? Because if you let u be negative x squared, we get du equals negative 2x dx. All right, actually the negative 2 doesn't bother me.
Yeah.
It's the x that's still there. So, and he's not up here to swap out.
And if we plug in just u to x, then we still just get
It doesn't do anything. So could we rewrite this in a way that we could create an extra u or a different kind of u? Like the tangent.
I don't know how that.
Yeah, e doesn't really do much good with anything else. Could we perhaps, finagle this to create a substitution of some kind? Yeah, like over there. I'm not seeing it. So ladies and gentlemen, this one's not doable, okay? This one, pause, this is actually more foreshadowing for Sloan. This is something we have to use BC on. And even BC won't give you the exact answer. This one is impossible to do by hand,
Have fun,
Do you
Sloan.
have,
okay? Impossible to
when
do
you
by
get
hand.
the derivative equal to that?
That's a great question. You can't.
Exactly.
Right. But let me point something out. There isn't a single function. I could not put anything on this board that you can't take the derivative of. You have product, you have quotient, you have chain, you have all these other things. I cannot put anything on the board that you cannot differentiate. They're all yours. But
There's no.
there are plenty of things out there that you cannot take the antiderivative of. Okay, for that is a big part of what the BC is techniques of taking antiderivatives of things like this. All right? In theory, it's pretty easy because we turn it from this into a polynomial that's close enough, and then we just take the antiderivative of the polynomial. Okay, that's in theory, that's the short answer of that.
And
And
which-
please understand that everything up here, not gonna be workable. Okay? Hopes and dreams. So nice try. They're not gonna give you any of those in AP. I take that back. Nobody has discovered this yet. If any of you do, tell me, and only me. All right? Complete with all of your notes and everything, and then we'll work something out.
And meet me in the shed back there.
You're right, yeah, maybe in the shed with all the axes and shovels, yeah.
What?
Are we recording?
I hope so.
All right, ladies and gentlemen, there's our lesson for the day. Go ahead and stop.
And Mr. Portman's plans.
Now, tomorrow, we are gonna look at what happens if I start putting